in mathematics.
Thank you very much, Anna. And for those who have just joined us, I'm Lois George, and I'm a senior lecturer in math education from the University of the West Indies Mona campus in Jamaica. My presentation focuses on zooming into the STEM pipeline, exploring participation and attrition in mathematics. And my presentation will take the typical format as follows: the background, the context, questions, results and discussion, and then conclusion. This presentation is based on selected findings from a 2020 publication in the Canadian Journal of Science, Math, and Technology Education, which explored the M in STEM, post-secondary participation, performance, and attrition. The image on the screen depicts a part of the STEM pipeline that is relevant to the research, and it refers to the educational and career paths that individuals pursue in the fields of science, technology, engineering, and mathematics STEM. The pipeline includes a series of stages starting from early childhood education and continuing through primary and secondary education, undergraduate and graduate studies, and into careers in STEM-related fields. We are zooming into the post-secondary level, and I have included 3 educational levels: high school, post-secondary, and university. In most countries, mathematics is compulsory in high school, but it becomes optional after this level. Post-secondary in the context of this research means after high school, but before university. You would note in this image that there's a reduction in the size of the pipes at each educational level as the number of individuals who opt to enroll in STEM disciplines gets smaller. The leakage represents the students who do not opt to do STEM subjects. And by the university graduates, we are really down to a trickle. In terms of the research context, it was conducted in Jamaica and included 71 post-secondary educational institutions and 15,220 public school students. This represents over 95% of the cohort over a 4-year period from 2013 to 2017. In terms of the research context in Jamaica, STEM is an essential part of promoting economic productivity and growth in Jamaica. However, while there's a growing demand for graduates from STEM disciplines, the production of individuals with STEM qualifications is not keeping pace and really needs to catch up. So therefore, one of the aims of the government is therefore to increase enrollment in university STEM courses and subjects. To fill this gap, the government, through the Ministry of Education, has vigorously promoted STEM education and literacy at all educational levels. It has undertaken several STEM-related initiatives, such as offering scholarships, raising awareness about STEM jobs and opportunities, and including STEM components in the national curriculum. However, there have been major threats to increasing STEM enrollment at the post-secondary and tertiary levels. We have 2 major issues. One is that of migration. There's a high rate of migration of STEM professionals to developed countries, and this is ongoing and increasing. Another dimension to the issue of STEM participation is linked to gender. Globally, and even in the Caribbean region, women are underrepresented in STEM fields, in employment and in education, largely because of the educational choices that they make at the post-secondary level. The issue of inequity has been considered to be a national and global crisis that warrants urgent research and intervention, hence this research. In terms of what the math program looks at the post-secondary level, it's a 2-year program, and the 2 key subjects or courses that students would take would be pure math and applied math. So there are 2 units to each of these courses, And some institutions would offer both courses, while some would offer only pure math. So for example, 71 of the educational institutions offered pure math, while only 17 applied math. In terms of what this program entails in terms of the actual modules, it is quite typical to what we would expect to see with courses like functions and algebra, mechanics, calculus, etc. But this is just to give you an overview. So on the basis of this foundation, this research focuses on how does the candidate participation in 2 math courses compare in general and by gender? And what is the attrition rate from Unit 1 to Unit 2 for each of the courses from 2013 to 2017? In terms of looking at the key definitions for some of the 2 of the major terms, participation is the completion of a full course of study and the sitting the related examination, which might result in a pass or fail. This comes from Lois 2009. And this contrasts with enrollment, which encompasses students who sign up to do a course, but who may or may not complete the course of study and who may not complete the exams. Attrition, on the other hand, is the reduction in the number of students from year 1 to year 2 at the post-secondary level. And this begs the question, does the pipeline analogy apply to the Jamaican context? So in terms of the results, for the participation in a math course, out of all the candidates who undertook post-secondary education, which was approximately 16,000 students per year, on average, 18% opted to pursue a math course. So considering that selecting a math course is optional at that level, and that in Jamaica, approximately 50% of students fail math at the end of high school, this finding was encouraging. But you see on the screen, this a 20% in a blue circle that has been used as sort of a benchmark. And the question might be, why use this benchmark? It has been mentioned in the empirical literature, for example, by Hodgin, who looked at similar concerns in England, and they reported a participation rate of 20 to 26%, which was remarkably small in contrast to global counterparts. When we disaggregated participation by courses, we saw that the participation in applied mathematics is considerably less than pure math, even for schools which offered both subjects. And this suggests that pure math is the subject of choice, or the course of choice that's favored by students doing math at this post-secondary level. And there are 3 questions that could arise from this finding. Why does this disparity exist? Why is the student enrollment for applied math so low? And what are the implications for university enrollment in STEM courses? When gender was looked at, there was a 1-to-1 ratio of participation in terms of males to females in the math courses, and that's overall. Looking at this result from an international perspective, the gendered patterns were slightly different from what would have been observed. So this is not unusual, really, because gendered patterns relating to educational variables such as achievement and attitudes have been different from international norms, and cultures and sociological reasons have been put forward for this, but more research is needed. Quite often, it has been reported that more males participate in math courses than females. Looking at the gendered participation across the units, we notice a slightly different finding just for one of the courses, which is the Applied Math Unit 1, where there was a ratio of 2 to 3 in favor of males. The other courses and units, the 1-to-1 ratio between males and females, this was retained. And just so that you see the numbers that we are dealing with, this is on the screen. Looking at the second research question and attrition, for both math courses, there was a sharp decrease in the Unit 2 student participation, having completed the related Unit 1 course. For applied math, from 2013 to 2017, the Unit 2 participation is about a third of that of Unit 1. And for pure math, it was 50% less, that's the Unit 2 participation, than Unit 1. For applied math, the attrition rate is higher among females than males, while for pure math, the gendered attrition is approximately equal. An examination of the attrition rate suggests that a large number of candidates who complete Unit 1 in a math course, they do not proceed to complete Unit 2. So the conclusion that I've made is that of students don't complete both units of their post-secondary education, and that is concerning. The attrition as well from Unit 1 to 2, it has been observed in other jurisdictions such as the UK and in Asian territories. In conclusion, approximately 1/5 of students who opt to participate in post-secondary education select a math course. And for our jurisdiction, this is highly encouraging. However, the data presented shows that there are marked leakages in the STEM pipeline from year 1 to year 2, which needs intervention and needs to be stemmed. No pun intended. Future research is needed to explore some of the reasons for the attrition that we are seeing, the major attrition that we are seeing, and targeted interventions are needed at the Unit 1 level to ensure that students are supported to proceed to level 2. Thank you very much.